Hello everyone, welcome to this talk on scaling OpenDaylight applications. We're going to look at different approaches that you can use to scale your application on OpenDaylight, as well as what you can do beyond that. When you look at the scale problem of any application, uh, two main approaches that you can take is one is vertical scaling, where you give more resources to the system. You give more CPU, more RAM, you try to increase the JVM parameters, tune the JVM parameters, try to get the most out of what you're getting from the system. And this is always the first step you should always take in scaling an application. Try to get the most out of the existing resources you've deployed. In addition to this, also you have to look at optimizing your GC pauses, trying to improve your GC parameters. Then look at the disk IO saturation, try to see how you can best utilize IO in your application. Very often you'll see that doing all these optimizations, improving your application workflows can only get you so much. At beyond a point, you have to look at slightly more drastic ways of achieving more throughput. So OpenDaylight provides what is called clustering, where you can have an application instance sit on multiple controller instances. So it is always 2n plus 1 number of instances, like an odd number starting from 3. So you can have an OpenDaylight cluster of 3 controllers, 5 controllers, so on and so forth. As you deploy an application on such a controller, you can designate one of the controller to be the master from an application standpoint, and rest can be slaves, or you can decide that, oh, all of them you want to designate as a master. It's up to your application design. But when you do that, you have to be mindful of what's the cost of deploying such an application. As your data requirements grow, so will the cost of replication on the cluster grow. Understand that the OpenDaylight clustering is a strongly consistent cluster. That means when you do a write on any one controller, it's going to write on all the controllers before your transaction finishes. So that's one thing which kind of slows down the system as you keep adding more data to it. So we eventually have to look at slightly different approaches to tackle the problem. One of the most prevalent approaches here is what we call as horizontal scale. So I'll take an example of two applications, one netconf, one OpenFlow plugin based, and see how we achieve such scale out. So this is a basic this is a single node netconf application which is running on one controller, and this has inbuilt netconf application which translates from set of data payloads on the northbound to the data payloads which are relevant for the specific devices. It also has basic services like the device credential to connect to the device to store the credentials for such connections. As we deploy this application, as we grow the number of yangs that we have to deploy for a different set of devices, uh, we notice that we have to keep adding more and more heap for such applications, because as you add more number of diverse set of devices, more number of device types, in current OpenDaylight, you have to bear the cost of all those schema trees loaded in memory. So this is clearly something which does not scale beyond a point, and you have to look at slightly more scale out designs where you can break up the application into different application components. This example application, we could look at breaking up the main application logic into the leftmost controller container, which is NC app, and then device credential container, and lastly mapper container. So basically, all these containers talk to each other via a message bus, and they have a message bus shim which helps translate data store updates onto the message bus. One thing which comes as a part of the design is, how do you know which device is managed by which such container? So that's defined by the device mapper service. And lastly, this all needs like a internal data store which is persistent, so that all application state can be maintained there, and the containers then become fungible. So these are the key changes that if you see when you move from a single application controller to a scaled out controller. Now we'll move to an OpenFlow plugin example. This is an example of an OpenFlow plugin based application running on a 3-node cluster in OpenDaylight. This is a traffic steering application which has features like point-to-point paths, point-to-multi-point paths, and it supports management of topology of such an application, being able to program reachability using segment routing, and also the application instance runs as a single master on the cluster on one of the controllers, as well as the devices run as master on one of the OpenFlow plugin controllers. If you look at this application, again, as you scale this beyond, let's say 500 or 1000 devices, you will see that you cannot keep adding more CPU, more memory to achieve scale. So we look at a scale out design and how this will pan out. The first thing we change is try to move away from clustering, because in the previous clustering model, there will be a lot of replication cost due to replication of operational and configuration state. As you move away from clustering, you then for availability need at least active standby model. So you can have an active standby managed from outside, as well as break up the application into slightly more nimbler microservices. So ODL does not currently have nimble distributions, but there is a ODL project called ODL Micro, which is trying to provide such nimble distributions that you can use in such scale-out designs. As you scale out using this ODL micro based distributions, you can then have all of these agents, so to say, talk via the message bus to the main application logic, and which sits in, again, ODL controller. So just to summarize, the way forward is clearly to go down the horizontal scaling path, and depend on a lot of these open source projects to help manage such a deployment. Again, always be mindful of what are the key requirements here, what are the scale bottlenecks. Try to surely achieve the most that you can from a vertical scale, and only when you're convinced that you can't go beyond based on the data available, try to move towards more horizontal scale solutions. Because as you can see, there is surely more complexity involved in moving to horizontal scale. There is more deployment headache that you have to deal with as a from an engineering perspective. And there are open source projects which can help you reduce your pain. Like you can use Prometheus for monitoring your applications. You can use Kibana or Grafana dashboards to help you understand where the pain points are. As well as you can use Helm to kind of help deploy your applications as application bundles together across such deployments on Kubernetes as your platform. Yeah, so I think this is pretty much what I want to talk to you on scaling. So please feel free to get back to us with your comments and engage further. Thanks a lot for your time.